Hello everybody, I'd like to welcome you to our 21st video in the pre-algebra playlist, and in this video we're going to go over the concept of multiplying and dividing decimals with one another. Now, one of the best way to get a good grasp on multiplying and dividing decimals is to pretty much do a lot of examples with it. So let's say in this first example you have something such as 1.82 times 3.98. So just like we did in the last video when we added and subtracted decimals with one another, one of the best ways to deal with decimals when multiplying them with one another is to again simply ignore them. So just like we did in the last video, let's first figure out the number of numbers I will have in my final answer after the decimal point. Now, if I was adding these two terms together, all I would really do is figure out which term out of these two has the most number of numbers after the decimal point. And then that's the number of numbers I will have in my final answer after the decimal point. But when it comes to multiplying and dividing decimals, what I really need to do is figure out how many numbers there are after the decimal point in all of the terms combined in the original problem. In this case, the term 1.82 has two numbers after the decimal points. Similarly, the term 3.98 again has two numbers after the decimal point. So, my final answer of whatever the product of 1.82 and 3.98 is will have 2 plus 2 or 4 numbers after the decimal point. Now let's set up this problem over here like this over here without any decimal points. So when I do 8 times 2, that gives me 16. 2 times 9 will give me 18 plus 1 will give me a 19. 2 times 3 will give me a 6 plus 1 here will give me a 7. Now I put a 0 over here. Moving on, I get 8 times 8, which is 64. 8 times 9, which is 72, plus 6, which will give me 78. 8 times 3, which is 24, plus 7, which is equal to 31. Since I'm on the third digit, on the second row, I need to put 2 zeros. And I get 1 times 8, which is 8, 1 times 9, which is 9, and 1 times 3, which is 3. Now I add up all these three terms over here together to give me a 6 over here, 9 plus 4, which is a 13 here, 7 plus 1, which is 8, plus 8, which is 16, plus 8, which is 24, 2 plus 1, which is 3, 3 plus 9, which is 12, and 3 plus 1, which is 4, plus 3, which is 7. Now, since I figured out earlier that my final answer will have 4 numbers after the decimal point, I need to put the dot right over here to give me my final answer of 7.2436. Let's do a couple more multiplication with decimal examples. So in this example over here, let's say I have something such as 2.89 times 1.3. Now my final answer will have the combined number of numbers after the decimal points in all of the terms in the original problem. So what do I mean by that? Well, the first term has two numbers after the decimal point. Similarly, the second number only has one number after the decimal point. And since 2 plus 1 is equal to 3, my final answer will have 3 numbers after the decimal point. So now let's set up this problem over here without any decimal points. So first I get 9 times 3, which is 27. 3 times 8, which is 24. But then I add the 2 to give me 26. 3 times 2 will give me a 6 plus 2, which will give me an 8. Then I put a 0 over here. 1 times 289 over here will give me the number 289 over here. When I add them together, I get 7. 6 plus 9 is equal to 15. 8 plus 1 is equal to 9. Plus 8 is equal to 17. 2 plus 1 is equal to 3. Since we figured out in the beginning that my answer will have 3 numbers after the decimal point, all I really need to do is put the dot right between the 3 and the 7 to satisfy the condition that we came up with in the beginning of this problem. So my final answer is equal to 3.757. In this problem, I have 1.891 times 2.11. Now the first thing that I can do is figure out how many number of numbers there will be in my final answer after the decimal point. In this case, the first term has 3 numbers, and the second term has 2 numbers. And since 3 plus 2 is equal to 5, my final answer will have 5 numbers after the decimal point. Now I can set this product up over here without the decimal like this. When I do that, I get 1 times this whole term over here, 1891, which will simply give me 1891. Moving on to the second digit, I can simply write the 0. And then again, when I multiply 1 by all of the digits on the top, I'll get 1891. Since I'm moving on to my third digit, I need to put 2 zeros down over here. So 2 times 1 will give me a 2. 2 times 9 will give me an 18. 2 times 8 gives me a 16, plus the carried over 1, which will give me a 17. 2 times 1 will give me a 2, plus the carried over 1, which will give me a 3. Now I add up all these 3 terms over here. Now I figured out in the beginning that my final answer will have 5 numbers after the decimal point. So I have first number, second number, third number, fourth number, and fifth number. And I put the dot between the 3 and the 9 like this over here. So my answer to 1.891 times 2.11 is equal to 3.99001. So in this example over here, when we're dividing decimals, let's say I have something such as 1.84 divided by 0.92. What I need to do first is figure out how many numbers I will have in my final answer after the decimal point. All I really need to do is figure out the number of numbers after the decimal in the first number, which is 2. Add that to the number of numbers after the decimal point in the second term, which again is 2. So my final answer will have 4 numbers after the decimal point. Now I can set this problem up over here without the decimal point like this. Now if you think about it, 184 divided by 92 is simply 2. One way we can check it is by multiplying the 2 with the 92. And if it gives me 184, then my answer is correct. So I have 92 times 2, which will give me 2 times 2, which is 4. 2 times 9, which will give me an 18. So 184 divided by 92 is simply 2. Now what happens to the number of numbers after the decimal point, which is 4? Well, I can technically write the number 2 with 4 zeros after the decimal point. So I have 2.0000 as my final answer. So 1.84 divided by 0.92 is equal to 2.0000, or more commonly, just 2. The first thing that I need to do is figure out the number of numbers there will be after the decimal point in my final answer. The first term over here, 0.72, has 2 numbers, but the term 36, the second term in this problem, does not have any number after the decimal point. So it pretty much has 0 numbers after the decimal point. So 2 plus 0 is 2. So my final answer will have 2 numbers after the decimal point. Now we can set this problem up over here without the decimal point like this. And since 72 divided by 36 is simply 2, I write down the 2 over here, and I know that 2 is a part of my answer. Now over here, we need to take a step back and think about this problem a little bit. In this case over here, our first number, which is the number that we're dividing, is less than 1. And the second number over here, which is the number that we're dividing by, is actually much bigger than the number 1. So when we divide something that is less than 1 by something that is way bigger than 1, then we know that our final answer will be less than 1. But now we have a 2 over here instead of even a 1. So what do we really need to do? Is my final answer 2.00 because I have 2 numbers after the decimal point? Well, no, I have to use the logic that I used over here, which told me that my final answer should be way less than 1, to realize that instead of putting two numbers, or basically two zeros after the number 2, I need to put them before the number 2. So when I do that, I get 002. And now I know, referring back to the beginning of this problem, that there has to be two numbers after the decimal point. So I put the decimal point right over here. And so I get my final answer as 0.02. Now this wasn't really a hard problem, but what you had to do was that you had to use a little bit of logic to realize that my final answer could not have simply been 2. It had to be 0.02 because my final answer had to be way less than 1, because when I divide a number that is less than 1 by a number that is way bigger than 1, there is no way that my final answer will be more than 1. And so that's it for this video. I hope you liked it and you enjoyed it. I hope you keep on working hard, and I'll see you in the next video when we go over how to solve equations that have decimal numbers in them.